Electronics and Communication Engineering course from IEEE University, Hyderabad. CSC in
सर लावत आहे लागत सांगू
find out that how do you what kind of information that you derive out of those states, those discs, those slides. It's like saying X-ray, and the radiologist can see the X-ray and say, "Oh, you have a minor fracture." It's okay. But what happens if you want to get beyond that? What if you want much ahead of when the patient has problems to find out what's happening? It is where exactly some of the best examples is either radiology or just similar fields of the very similar from finding out the diagnosis problem in so-called pathology, right? Pathology, unlike let us say radiology or imaging, is something, some part of your body, liquid, blood, what most of the time, let us say biochemically or kind of chemically tested, right? So therefore, in both ways, finding out what is wrong is the way to kind of identify abnormalities, and then you can extend and say that okay, we are not talking about X-rays which are more than 100 years old. In fact, the guy who invented X-rays was the first Nobel Prize winner in physics. So, I don't know what we are talking about. What are the other advanced? Suppose you know more than me about MRI, CT, etc. But I will kind of maybe take you a little bit beyond that and talk about how this whole thing gets developed. And you will realize very soon how interdependent, as I said yesterday, a little bit, of various fields of technologies, science, mathematics, everything, and that brings value to what we are here and what we are getting figured out. Just talking a little bit, maybe more on importance of what the radiology or imaging is important. Look at this picture that unfortunately this person needs to have a kind of a tumor. Right? Of course, this was catastrophic at some point of time because somebody has tumor and that is the end of life for somebody. But today we want to talk about how well I should be able to locate. By the way, this is not scale. It's not that this big compared to the area of cross-section. It is very tiny, maybe less than a centimeter, maybe 2 millimeters. Okay. What you want to find out is its exact location. Why? Because I would like to kind of use so-called proton therapy or some other therapy, etc., and look for exact location so that I will be able to aim and shoot in some way. It's called a protocol. How well I will be able to kind of locate it so that I know precisely aim at, it's like gun in some way, right? Gun of protons, gun of ions, and so on. Point is that if I am not able to locate it properly, it's likely that I will spoil all the big cells. Which are on the way, right? So just instead of kind of killing only the affected area, but I'm going to kind of kill even the healthy cells and so on. What is even more difficult is sometimes it exists not necessarily just at the outside, they can be inside a body. So how will you locate them very precisely? That's where the imaging kind of going to play a big role. And of course, it's a different part that I've shown. I'm not asking to kind of treat this, but how the so-called track P that we sure some of you studied, but P for us it is a way of life in some way. That the if you kind of look at if I can shoot certain beam as a function of depth here, and it follows a peak, which is like as if the kind of let us say the dose that is delivered to the body is going to kind of have a speed. But what is important is when it falls down very rapidly. I want to adjust this in such a way that it actually centers at that particular tumor. Okay. By the way, some of you who have gone to sleep, I want to kind of say that this Nobel Prize that was given was actually given to two Braggs. That's why it's called Bragg B. And you may be interested to know who this other guy is. This guy is son of this Bragg. And more importantly and more interestingly is that they shared the Nobel Prize. And I think the bottom line is he was 25 years when he won the Nobel. He was the youngest Nobel Prize. Okay, that's interesting. His life is really not just about talking about certain things, but the way it is done is very interesting. Now I'm showing something which is slightly different, so slightly away from AI, but I'll actually come to what you can do if you also kind of happen to keep your vision open and kind of see what are the developments that are happening in the concurrent field. Here is an X-ray film equivalent to an X-ray film, which is called a sensor chip. It's the same as like what you know about a integrated circuit. There's a chip, it's a small one, maybe 1 inch by 1 inch chip. But what is important, unlike a kind of X-ray film, is okay. Rest is same. You use X-rays, same X-rays that you're talking about. You will have an object, maybe things or someone else, and the X-rays go through this. It goes through the sensor chip, produces electron pulse. It's studied first year, last one, and then they put this picture here down. What you have is a big matrix of 256 by 256 matrix of only about 50 micron kind of thing. In case you wonder what it is similar to the kind of a chip that you all have in your camera, right? I call camera not cell phone because most people use camera only to take film, right? Once in a while we talk. Okay, so an important thing is look at the interconnecting technology. One is able to kind of connect 6 by wire bond, and you have the entire chip sitting here, which is actually processing this data. It looks very unconnected to AI, right? The theme of this concept. But what happens is that when such kind of picture, that kind of sensor gives you a picture after you click it, it looks something like this. Nowhere near what we talk about in X-ray film and so on and so forth. This is where the machine learning comes to the picture. I want to understand what these little bits to sensor. Now, if I'm able to kind of label each one of them in my language, then I start seeing different colors. You can see they have been now all are blue here. Now you can see red, green, blue, etc. I also want to go and cluster them. I want to go and bring them together. Identical ones to bring them together. Now I can see that, oh, there seems to be some method in madness. I can kind of see some of them are like polylines, some of them like dash lines, some of them looking straight lines, some of them like blobs, right? Oh, it's very interesting. I could have them instantly if I know a little bit of material science, let's say particle physics or shear physics, whatever. I can clearly say that with a little bit of understanding that dots, they better be photon. If they are blobs, they better be somewhat heavy particles like ionized particles, and so forth, so on, so on, so forth. What did it tell me? It told me that there was a semiconductor guy who actually built a super fantastic sensor, but there are also guys who are sitting in physics department and actually get sense of the data, and then ultimately brought down and kind of said that, hey, this is like this. Like, what did I get at the end? At the end, what I got is a picture like this. Of course, it's a mouse, you can see, and I kind of used the visualization software and displayed everything. And said this mouse is having all the elements that you can think of what you and me and mouse have inside. That's not very interesting. It's like an extension of going inside, right? Now I tell the system, okay, remove certain things out of it. I remove one scheme out of it, and they will now say, cut out you and only want to see the code, the gadolinium, iodine, etc. If you are a clinician, you will say, no, I want to remove completely all that other things, only revealing what is inside. Now you are talking about molecular level of aging. I'm able to tell you, X-ray gives you maybe an argon level, maybe some other technique to soft cells or hard cells, etc. Here we are talking about element by element. We are only going to kind of show you the thing. This is the power of AI, right? Because just having an image is one thing, but making a good sense of it to say that this patient is going to have a disease 6 months from now, 6 years from now, maybe 10 years from now, really brought a fantastic revolution. So big revolution that this particular invention has become a big splash of news a few years ago, because this is the first time after 100 years of X-ray imaging that something what is called a color X-ray becomes possible. Those are the kind of developments. But in order to do that, in order to see this, we cannot just confine to one small aspect. To see the developments that are happening in the integrated circuit, application, the simulation, all that. This is where you migrated from color to X-ray. You can really see every picture that's kind of ready. What I'm going to talk next is something very familiar to many of you must have seen this kind of slides. What we really want to look at numbers in here, what level of perfection, maturity, okay, what you call sense of talking about either sensitivity by which you are able to say something an S and an S, it's two positives, and or so-called specificity to talk about how you identify those of which correctly identify as two whatever called two negative things. Not there, so not there. Yes, they're there, it's there. But can you really make something between these two? These are the kind of two positive and two negative. One is talking about ordinary X-ray field, ordinary X-ray field. Now I'm not on the color X-ray. How to be able to not just identify the problem that one has, one is able to kind of quantify whether a patient has certain numbers. It's just integrating the area under the curve. Let us say a particular volume. But the point is that AI has given you a kind of quantitative measurement of so-called corona score, which you are not just talking about patients suffering from corona or not, but actually say as the patient goes through the treatment, I'm able to kind of monitor almost like condition of a patient. That is the kind of power of AI that you talk about. And when somebody develops a network of maybe 100 node, 120 node network, one is able to, of course, you also have to train 100,000 samples or even more than that. You talk about radiologists, you talk about particular network, so-called test net, and if you look at these numbers to say that this was able to achieve a perfection much better than the human radiologist, then you know that AI has come down from a agent. That is what is kind of driving the medical imaging and medical science in general, right? Of course, the moment you kind of able to have such kind of power, some extent the diagnosis and treatment becomes somewhat easier. Why? Because it's like a lookup table, and I have this particular kind of evidence is coming from pathology, coming from radiology, and etc. So there is almost one-to-one correspondence. But even then, it is quite possible that one is able to get confused to some level, just because it depends on doctor's experience of seeing how many patients, what sector, what section of people. Is the doctor from urban area? Is the doctor sitting in the village? Is it from private hospital, government hospital, etc.? It goes by some kind of knowledge that you have gained. But on the other hand, if you have an AI network, which is of course well trained, then it's much easier. And to that bad, AI doesn't have like all emotions, sentiments, etc. So therefore, there is a more, let us say, objective kind of identity of problems and so on. One of the biggest things I think that now is going beyond just looking at the data and able to make judgment about it. It is something about able to kind of predict something we are not sure whether how to kind of look at the data and interpret. But most importantly, is forecast, because when we go one of our loved ones are admitted in the hospital, the typical question that we ask. Doctor, will he be okay? Will she be okay? And how soon my father or mother or whatever comes out safe from the hospital, etc. Doctor always says no problem, everything is fine. In 3 days, to some extent, it depends on the doctor wants to talk to in a positive way and so on and so forth. But can he or she, I think, given the situation of the patient, the radiology experiment kind of going to bring out, can anybody really say what is going to be the condition of the patient, let us say, if we take from there, few months from there. AI system probably slide. I wanted to do this first. One could really to have enough data for the patient, which are various types of patients. Could be social behavior, genomic, sensor, lot of data, pathological data, physical activity, family history, everything. If you are able to kind of feed all these kind of data to a very complex network, people were able to kind of prove with a high sense of sensitivity that what is going to be the outcome of the patient. If the patient, one was able to kind of look at this is very encompassing kind of field here. You are talking about an embryo, talking about interpreting a newborn baby, and we are actually talking today whether the patient is going to come out of the hospital live or dead. That is very encompassing. That is really something which you can't even imagine. The best of the doctors could actually say objectively. I'm not saying that this is a great thing or not great thing, but the point that comes to is we have reached that kind of, let us say, maturity in logic or in this area that we are not now talking such topic, but we are talking about something which actually is making products which are going to be useful to the common person. This slide is just coming back. Again, the same thing during the COVID. I can't stop examples. Probably the first time that you have actually seen vaccines and drugs coming out in 6 months' time, 1 year from now. How is that possible? In the normal conditions, it has taken 7 to 10 years to kind of discover a new drug and put it to use. That has been possible mainly because of two reasons. One reason is in some way they use many of the technology that are typically used in studies like accelerators and so on. Believe me, there are more accelerators in the hospitals these days than in science lab. That really tells that how the physics or how the science in general has come into the human, let's say, applications for human life in some sense. But AI also has been kind of very efficient and very well to expedite the drug discovery that you have seen, just because you are adding a lot of researchers and that search for the new drug candidate. Why? Because when you talk about a drug, it is actually a combination of certain molecules. Now, in order to develop a drug at the fundamental level, I should understand the combination, firstly individually or molecule, and also the combination of this molecule and how will it affect, let us say, the particular elements that you want to catch on, right? Now, it is beyond humans' comprehension to see. I have hundreds, maybe thousands of such molecules. How will I know each one of the interactions with other, the outside bodies that are coming into my body and then kind of causing such disease or whatever. But AI becomes easier because you can actually search very quickly, right? So therefore, the faster that you are able to kind of eliminate or at least focus on a particular kind of set of molecules, the faster the drug gets developed at a chemical state. Now, converting chemical kind of a medicine into a drug is the next stage, but which is relatively easier and better. So AI actually helps those areas. The other very important field which has become now the field that kind of both biologists, genomics, AI experts, and many more supercomputing guys, including, they are actually spending their time because the healthcare industry in the recent years has been the biggest beneficiary of research into genome. Again, it's the same thing, combinatorial problem. How do you kind of narrow down search? Into getting into the because genome is ultimate building block, ultimate thing that decides literally your entire lifespan. What you're going to become, what diseases you are going to get, how you are being die, etc. All decided by that firmware in the computer language. And that seed that everyone is not done by a kundali. It is not that the person who tells you a kundali will tell when you will die or when you will get married. Okay, get married. So it doesn't happen. It all happens because of the signature. If I'm able to kind of process it very convergently and very quickly, that tells me how I get to kind of look up and get benefited. Of course, it may not be every time a good idea to know when I'm going to die, but kind of coming to this. If you ask me, if you are a person who wants to do something that really affects every area of physics, every area of science, every area of engineering, it is material science. Material science are used by knowledge, used by civil engineers, they're used by quantum computer guys, and for space technologies. You name anybody, everybody wants to know the strength of that material, the usefulness of the material. How do you invent new material? Same story like genomes. I require to kind of able to extract out of tens of hundreds of thousands of material, and every single material, in order to discover, I have to take it to lab, I have to understand the properties, and I have to come back and say, oh, this material is useful, not useful, and so on. If you have AI, it can actually search those thousands and maybe lakhs of such materials in no time, and able to kind of give you an idea. I want a superconducting material at the room temperature. Maybe I know only 4, maybe 10, maybe 15, maybe she knows about 100 of them. But these can kind of throw literally unlimited number of materials. It becomes very easy for me then to get that family of materials and able to kind of narrow down the kind of search. What is more, it is able to kind of give you even a feel for discovering a new material, which I didn't even expect that material combination or its kind of compound is going to give this completely unusual property. For example, the material is very light but extremely strong. Then I straight away say, oh, this is the right material that will be used for let's say space technology, and so on, right? And those kind of insights and able to predict, able to kind of give idea for new discovery is something single largest benefit of AI that has changed the whole world of material science, so on and so forth. And it's not just the physics, it's not just science, but as I said, it's going to affect very, very well a lot of new engineering challenges. And if are not possible now, they actually become possible these days because of it is here. Yesterday I was kind of mentioning that how important that these guys who are fathers of let's say the AI system, okay, so Hinton and Huffley who are actually in some way which has started the whole field of AI. In fact, Huffley says that this is not just what you are working on, but its important thing is how you are working on AI that way has really revolutionized all these fields and affecting really wonderful progress. Okay, they of course started obviously with what is here for them to kind of look up the human brain to kind of emulate, but things have gone quite far from there. I want to take a digression for one to kind of show you that since I said niche areas, one of the areas that we work on is so-called particle physics or high energy physics, where we kind of take basic elements like protons and make them rotate around a big circle of 28 kilometers and make them come and collide with each other, and then study what happens in a particular place. I was here, but there are other people working in other places, and this is done some place in, let's say, it's called CERN. Why I'm showing this? Look at this instrument. It's a person here. We are actually talking about building gigantic detectors which are about 14 kilotons of thing. There are hundreds of billions of channels that you need to get the data out of it. Sorry if I'm taking you too far away, but now I want to bring back to you, and I want to say that you are actually talking of producing data which is, let us say, 3,500 petabytes per day. 3,500 petabytes per day, right? And you talk about, let us say, Facebook, which uses so-called big data. They talk about 180 petabytes per year, right? That is the kind of scale that you kind of talk about. Now I want to do physics where, when such things happen, 25 nanoseconds, I want to find out one such great event, an event which will give me a Nobel Prize. Can you do it? Right? Can we can't. None of us can do it. Right? We now, yesterday, sir was talking about how semiconductors, in some way, that's what is important thing. You have to look up broader picture. Somebody sitting in some lab somewhere was actually building such kind of massive chips where you can put all the electrons that you can dream of, every unit that you can think of, memory, processors, interfaces, in one chip, right? And so those kind of chips you go and actually look for such kind of search algorithm. Where what you run to run basic learning architectures inside such, it will be able to kind of crunch these billions and billions of events, right? Now, what is the result? The result is you want to look at such kind of splash of events that are happening every 25 nanoseconds, thousands of them, and use your standard algorithms that you have, mastered in AI, ML, etc. Of course, you also need what I showed you before, FPGA, GPU, some of the TPUs, tensor processing. When I put all these together, the result is going to be spectacular. On July 4, 2012, you will find one such incident which will give them Nobel Prize, and 2013 probably they got Nobel Prize. This gentleman was waiting for 60 years for this event because he has actually theoretized very well, but somebody has to prove that in particular. Now that is the power of AI in some way. How you can speak up so kind of things. Of course, I think finish in 5 minutes or even less. So, but AI is not end of the story. I mean, one of the things that we need to kind of work out is AI is still largely a black box. It gives you fantastic results, but physics, in science, we can't say accept only the answer. We have to see how you arrived at it. I should be able to see what the prediction accuracy that you have, how you are able to, I should be able to trace how you arrived at this particular solution. All these you people call it as somewhat explainable AI. That's the field which is important in order to kind of move forward. While you people are thinking about it, there are a set of guys sitting in the next room. They are actually trying to work in quantum computers. There are even more forward people trying to kind of make what you call pure computing, pure market computing, etc. Quantum computer, of course, has already been different country. But when you talk about quantum AI, it's going to be issues. So just like what you have digital bits, you also have compute bits. In India too, right now there are 4 major verticals. People are working on various aspects of quantum computing. And I think in 5 years' time, the idea is that we have to make at least the quantum computing in 100 nodes. Right now, what we have is 6 node species, and the IBM has about 1,000 node species today. China has about 500, so you can actually see the roadmap very clearly kind of talking about. I told you something about a neuro cortex. This is completely a different paradigm. Instead of putting up things in a digital domain, we know that everything happens in our body in an analog fashion. Can I kind of build a system which does processing in the analog rather than converting it to digital? Why do you think that this solve our problems? Because what is all happening in this is actually something we want to simulate. So I think these are the roadmaps that one has ahead. So today, and some of you, when you become 60, you might still make such presentation here and say what are the technologies that are going to be there in the next 100 years. But all I want to, if you want to take just one message from my talk, is that the keep your vision a little open to see what are the competing technology areas that are going to benefit for your own work. Could be science, it could be technology, it could be engineering. Because if you take out the engineering out of science, it just becomes like a talking about Gyan, in some way philosophy. On the other hand, you should not also take out science out of engineering, because then it simply becomes violent. You change the voltage, see what happens, it works, change the voltage, it works, change the wire, connect this, becomes a silent error. The best thing is to kind of go through a very systematic study of what you're doing, all the engineered products will kind of work. All the best. Thank you very much.
Thank you so much, sir, for your talk. Let's see if anybody is having any questions. We will move forward to our next talk.
मतलब 3 o'clock खत्म कर मतलब 2 मिनट
With the focus on manufacturing automation, this research encompasses CNC technology and advanced hybrid manufacturing. It is also passionate about developing growth ambulances capable of operating in urban spaces among rooftops. This work emphasizes the full spectrum of machine building, covering hardware, software, analysis, simulation, and experimentation, with applications serving as byproducts of his innovation-driven research. He is currently advancing two electron beam hybrid manufacturing products with a total project funding of 11 crores, focusing on power bed fusion and multi-wire cladding. May I now request Karan to please.
Going to submit such late. I think why this name. Oh, okay. You can share my slide. Please, sir.
Very good afternoon to all of you. Thanks for seeing how people awake. So my job is here, but first I will take 3 minutes. So the title of my talk today is hybrid manufacturing. I'm not an electronic guy, but as I told in my previous session, I don't stay inside a circle. So by degree, I am a mechanical engineer, but I don't really care. I work in whatever areas that excite. So hybrid manufacturing, I'm going to talk about this machine. This machine is the culmination of my wire additive manufacturing research for the last 3 decades or so. It's a very huge machine, about 6 meters long, 4 meters high, 4 meters width. You can see that the 2 3 meter wide beam is lifted and lowered. That is our direct. And here we have put workers and this is what I want to cover. Now I planned my presentation. So 4 slides are available where I quickly talk about what is additive manufacturing. Then I talk about hybrid manufacturing. In hybrid manufacturing, even now people are talking about addition and subtraction, but we have gone 5 levels ahead of. I'll talk about that. Hybrid manufacturing for 2 things: hybrid processes and hybrid technology. Then, time permits, I have 3 slides in which I'm just giving photographs of our electron beam hybrid manufacturing. So, a little bit of definition about additive manufacturing. This is a well-known fairy tale. So I don't have to go into the story of it. The story. But here in school, the teacher gives this as the moral of the school. Stay together with the faith. Okay. So for college students like you, I would like to give another model, which is divide and conquer. You are all liars. So you divide and conquer. And I have here conquer. It finds applications in many areas. It's effective technique. But example, when the British came to the country, they divided the provinces and then captured one or the other, similar to the house laws. Okay, now in engineering, you have to find the use. If you do CAD modeling, take a lot of primitives, combine them using Boolean operator. Look at the screen. There are pixels. The screen is divided into small pixels. And you win over each pixel by mastering them. So this is all divide and conquer, but divide and conquer is not a good technique, but very effective technique. So you have to understand what is the bad part of it and then try to over. For example, pixels. If you go for smaller and smaller pixels, you will get better. So we can over. So what is divide and conquer in additive manufacturing? Take a 3-dimensional object, slice it into wafers, and then wafers are easy to manufacture. So because they are 2D instead of 3D.
they put 1 over there. So that is one important principle of additive manufacturing. That is divide and conquer. You divide a three-dimensional object, degenerate into 2D, and then capture it. Build 1 over. Second important thing is support mechanics. In any three-dimensional object, there could be undercut. I have shown the water tank. So building up to this, it is easier. Then suddenly it becomes overhanging. So you need to put scaffold. 3D objects also when you build, you will encounter such situation. So you have to have an automatic mechanism that will build gaps. So in each 3D system, we have these mechanisms available. I will not go into the details. There are two principles. One is divide and conquer. Second is support mechanism. Divide and conquer gives you an error called space error, surface creation band. In the case of support mechanism, when you remove the support, those places will have poor surface. Therefore, you will find that manufacturing parts have poor surface finish. The surface finish problems arise out of the two principles of support. Now, coming to the positive part of it, people first thought it gives you total order. You don't need a human being to write an NC program. Okay, you write 6 1 NC. In a way, it is here. Right? Don't need a human being. So we say it is R2 bar or physical CAD model to the physical object. So total automation was the very first according to art. But then subsequently it so happened that they realized that it's capable of several interesting geometry features and several interesting material features. So on the left side I have shown you can make assemblies directly. We are on assembly. 3D printing can lead to direct assemblies of this nature. This is an internal object used manufactured out of 30, 40 components and then welded together. But today it grows out of powder. So assemblies can be realized directly. You can have holes which go like this, take around and come back. Very complicated internal ducts can be created using additive manufacturing. Customized design. That is the structure of objects. These are all possible. So these are the geometry capabilities of additive. Coming to the material side, whenever we see a material, if it has some inhomogeneity or porosity inside, we check if that's it as a defect. But look at every natural object. All of them are inhomogeneous by default. Oriented. Look at your hole. It is having a tubular arrangement inside. Then as you go upward, outward, the porosity slowly decreases and you are smooth surface. Cut a tree and see how the plastic. None of the natural objects are homogeneous. But all man-made objects are homogeneous because we don't test it regularly. We have additive manufacturing process where you can have titanium of one composition here, titanium of another composition. Porosity of something in one place, porosity of something else in the other place. So today we are able to play with the interior of the object, both in terms of the composition and also in terms of porosity size. So that is becoming possible. It could be magnetic on one end, totally non-magnetic on the other. Copper on one end, aluminum on the other end. So all these are becoming possible. In fact, once a doctor told me, I want stainless steel here and I want titanium. Because the fellow should be able to move it nicely. So the doctors are dreaming in that direction. Today the technology is available. So because of these interesting geometric and matrix capability, you are able to engineer it the way you want. Designers are still grappling with the necessary tools for the analysis, but we manufacturers have the produced. So it is becoming a research technology of this era. The interest is going on. That is about the inspection tool. Additive manufacturing industry for some presentation. Okay, 13 minutes. I'm coming to my hybrid manufacturing system. As I said, it's about 3 decades of my research in wire-based additive manufacturing. Globally, today they call it a BAM. 2 years they put wire or additive manufacturing. I have dropped 1A because we not only deal with art, we also deal with laser. And for the last 6 years, we have been working on electron beam purpose. So we do WAM, and this is synergic integration of ideal processes and multiple technologies. Very often we use these words interchangeably. By processes, for the purpose of this topic, we will call it as things which work in a complementary manner. They are basically not competing technology. I can make a component from a block by machining. Or I can have powder deposit layers and then sinter the layers and then put it. So additive manufacturing by itself can put it apart, or refractive manufacturing by itself can, or I can take a sheet, formed over a die, I can still put it. So it can be plus, it can be minus, it can be zero. Okay? These are competing technology. We try to make them work together in a complementing manner. Then we call it as process. When I say talk about technology, I talk about milling, I talk about preheating, I talk about hammering, I talk about inspection tools. Because the purpose of complementing them is to get a benefit of. The purpose of putting these on the same system is to avoid movement from one place to other. In terms of accuracy, that is the goal. I just finished this part of it. So this machine was developed in Bangalore. We basically make the CAD model. We run around. My job is to get money from the government and other sponsors. Then we place identity party, place order on them. We give the CAD model, we give the concept, and then I dump. I hire a house in that city, dump a few students there. I visit every week. So we spent about 4 years in 3 years in Bangalore, 3 years in one entire boy. We were there for almost 4.5 years during the pandemic week. So I used to every week when I used to go, I used to do the test for corona, and I used to remain tense to become negative. So that is also, we remember. Okay. So as I told you, people are talking about combining plus and minus, but we have started doing it for the last 23 years or so. That's what I call as approach. Plus, minus, or we combine them. And then we combine different slicing strategies. Then we talk about different kinematics, 3-axis, 5-axis, or it could be scissor kinematics or other kinematics. Biorobotics is something we have recently done. In terms of energy, use electric arc in the form of arc. We also use laser. In terms of material, so far we were working on single wire material. For the last 2 years, we are using multi-wire material. So we have a 4-wire feeding system. At the center, it could be thick tip, or it could be a laser, or it could be electronic. 4-wire from all 2 sides. 2 wires can be titanium, 1 can be vanadium, 3rd can be aluminum. We can control the velocities of all 4 of them, plus the 5 degrees of motion of the biax. So it is a 90 stuff. We can realize a 3-dimensional component with variations. Okay, so that is the machine that I want to talk about. So we call this machine as multi-station, multi-axis, multi-material hybrid manufacturing system. 3 M's are there: multi-axis, multi-station, multi-material. Because so this is a 5-axis and it has any station. So multi-station, multi-axis. And then we have a wire feeder which has 4 wires. And so this slide is talking about the first level of hybridization, which is plus, minus, and 0. By 0 and arming operation, including casting. So, as you all appreciate, additive manufacturing is called plus and minus, subtractive has its own plus minus, forming has its own plus minus. Our ambition is to combine only the plus, bypass the minus. That's how we have done the system. So we call it. So if I have to take a geometry like slice it, take a welding system, deposit it there. One of the layers to show it has a scallop. Okay. So every time we put the layer, we do paste, just flatten it, yeah, big cutter. So that results in better dead because scallops are removed, so you have a good surface and it becomes an acid surface so that the next layer can be deposited nicely. It can also be used for optical inspection. There is any other flaws, it can be revealed. Then it can also be used for stress relieving because when milling happens, milling inherently applies vertical load. All stresses in additive manufacturing are tensile in nature. So when there is a vertical load, it applies compressive load to the nullify. So this is so this is the very first one for 30 years. So this is the CAD model. It's a horizontal flow, but we use 5 axis because I told you support mechanical pattern feature. We don't have support mechanism. That's what we did. So we overcome the need for support by tilting object in 5 axis. So that is one. Second is traditionally people throw horizontally of constant thickness, and if you look at the edges will be. But this is how people are traditionally doing. Now you can go for instead of being the vertical edge, you can also make it slanted, or you can make it curved edge so that approach the actual geometry. This is one way. I call it as edge order approximation. The other one is adaptive. You can have different. So this is planar manufacturing. The layering is planar, but none of the biological systems are planar flow. You know, we started from flow, so the flow line. So we are going for that type of. We have developed a methodology by which I will be able to grow object in a conformal. So we have different types of sizing methodology. The video will list. We also have a laser-based system we bought it from Pranova. Currently, my student is developing his own. So the wire comes from the center. 3 lasers attack it. The molten pool build the wire and then it goes. So we have wire cladding using laser. We have wire cladding using MIG. We have wire cladding using electron. So the same impeller I showed in the previous video. So this impeller, we can look at it in 2 parts. The inner one, which is simple and going upwards, converging upward. The other one is the complicated plane. So the inner one, we use bridge welding, planar cladding. The outer blade, we deposit like conformal, one bead over the other, all the beads are built. So that is how we this part. So for the blade, we use laser 5x. For the inner one, we use MIG and horizontal simple blade. So that video I will show you. So you can see that the horizontal deposition process happening of the hub. After that, the hub is finished on the same machine. So this machine can do milling as well as deposition. So the hub is ready now. Hub is built now. Then it will switch over to laser cladding. You can see that it is going a 5-axis way. And then the growth is in a conformal way. So in this part, we have achieved 4 levels of hybridization. Plus and minus by default. Then it uses different slicing concepts, horizontal growth as well as conformal growth. In order to get the conformal growth, we need 5-axis mode. So the hub is produced in 3 axis and the blades are produced in 5 axis. So finding the object is. This is our multi-wire system. We have the tip somewhere here, and then the 4 wires will be fed. And this is the fabricated rider. Entire thing was manufactured in Mumbai. So you can see how the work is happening. It also oscillates. You know, when the wire goes in the molten pool, they have different compositions. By the time they mix, they may freeze. So we ensure that given oscillation, that is one part. We also give an electrical oscillation. We don't use this, use a pulsed DC. So that also causes so that is about the 5 different hybridizations. Now I quickly talk about 2-3 technology. By technology, I am talking about rather than doing on multiple machines, we have it on the same machine. So typically, as I said, in additive manufacturing, you will have tensor resistors, the component tends to mark like this or break from the root. So you can even see there's a crack possible because of the residual stresses. So to avoid it, we either try to minimize the chances or after the deposit, so we have a pneumatic hammer. Just apply 5 bar pressure, it starts vibrating, very similar to massage. Just roll it over the surface. And here we have a 25 kilowatt detection heater. You can heat the surface before we deposit. So this is the hammer. And the heater. So this picture is video shows the complete process. So it's going for preheating. So this is the detection preheater. So the previous surface will be heated, taken up to about 500. Okay. Then it will come back to the cladding station. So this is our laser cladding system. So the big cladding system, I think next comes the big cladding. So the big cladding is come down. Now the cladding is taking place. After that, it will go for these building. Now it is undergoing face filling. Then you have a shiny surface. Then it will go to camera. The camera will look at it. But when it's satisfactory, then it will go for hammering. Now it's a camera which is looking at it. This is a simple camera for our test report. It can be anything else also. Now some X-ray diffraction head that also can be put on. So one of the stations is dedicated for inspection. Yeah, this is the hammering action. So the hammer applies compressive stress to nullify the tensile residual. Okay, now try to short. I just want to show our powder bed based additive manufacturing system. This we introduced the very interesting method of powder spreading. Nobody has done this. We got inspired from dosa. The way dosa is spread, you put powder there and then spread. This is our sand spreading machine. Same thing we have adopted for our powder machine. This is a huge machine. Of me. They live in Ahmedabad. So he has submitted the piece much time. It's enough to go over. So this machine, I mentioned my machine, the experts have cut it like this. I didn't understand. It was logical to cut like this. It took me 2 weeks for me to understand. Inside, there's a complete 5-axis motion system, and we lift the whole thing up 4 meter tall, 2.2 meters in diameter. This is a metal where they want to use sheet metal. So this is a deal of sheet metal. It's still the same electron beam. Sheet metal is the last stop that we will bring the out. Now it is the conclusion. Octopus, we call our machine octopus because there are many tool heads. So it is MS, MA, MM, multi-station, multi-axis, multi-material hybrid manufacturing system with the combination of over 3 decades of work and over 60 crores of various agencies. Technology transfer is available, and hybrid process in reference to technology are competing with each other. But in our process, we make them complement. And then multiple technologies we use them for optimizing the time and improving accuracy. So these are the 5 hybrid process. multiple technologies. Electron beam's major advantage is you don't need another inert gun because it is vacuum itself. So beams are something like 10⁻⁶ millibars, very high vacuum for manufacturing. Not for you build. You deal with 10⁻⁹. Okay, so with this I conclude. Thank you very much. Few minutes I will exceed your.
Thank you so much, sir, for your wonderful talk. So, may I now move forward to our next program, that is the Valedictory. So, good afternoon, distinguished guests, esteemed speakers, delegates, and dear participants. It gives me an immense pleasure to welcome you all for the valedictory function of the second IEEE-2024 International Conference on Artificial Intelligence in Healthcare, Education, and Industry. So before we begin with the function, may I request all the dignitaries to kindly seek blessings from Maa Saraswati and Tilak.
सर कनेक्ट करा कनेक्ट इथून स्क्रीन शेअर कर किसने कनेक्ट किया कनेक्ट लोग कनेक्ट पर क्लिक करा तो तुम ज्वाइन हो चालेल हा सर 2 मिनिट विराज
तू तुषार हार धावताना या शुभ्रवस्त्रावृता या वीणावरंतच्या मंडित करा या श्वेत पद्मासना या अच्युत शंकर प्रभुदेवी दैवै सदा वर्तिता सामा तु सरस्वती भगवती शदाड्या पहा निशेष गाड्या पहा निशेष गाड्या पहा
for the university.
तेजस ब्लूटूथ चालू करो उसको।
I would request
क्या नाम है उसका? उसका नाम क्या स्पीकर पर ब्लूटूथ कौन है? BD 83080।
So over the past few days, we have this confluence of brain mind, guidance, and groundbreaking research. This conference has truly been a platform for learning, sharing, and envisioning the future of artificial intelligence in healthcare. Like full keynote sessions to engaging discussions or research presentation. We have explored how AI is transforming education and research in all the sectors. It's time to reflect on the highlights and formally conclude this remarkable journey. For this, we have with us today Honorable Dr. Utsav Bhosle sir, Vice Chancellor, Sanjay Guravat University, Kolhapur. He is joining us online. Dr. B. Satyanarayana sir, Scientific Officer, CISPAR. Dr. K.P. Karunakaran sir, RD Chair, Department of Mechanical Engineering, IIT Bombay. Dr. P.P. Roy, Professor, Center for Nanotechnology, IIT Guwahati. Mr. Chiranjeevilu S., IT Head, India and Middle East, Lubrizol Advanced Materials. Ms. Josephine S., Senior Technical Officer, Electronics and Electrical Engineering Department, IIT Guwahati. Dr. Gaurav Mishra, sir, Pro-Vice Chancellor, DMI-GRDU. And Professor Dr. K.T.V. Reddy, sir, Dean, FEAD. We have all witnessed these knowledgeable and fantastic 2 days of the conference. So before we begin with, I would now request Dr. Gaurav Mishra sir and Dr. K.P. Reddy sir to kindly felicitate Dr. Karuna Karan.
Presentation. Presentation time देने वाला मेरे इसको.
May I now request to for the floral welcome, I would request K.P. Reddy sir to kindly welcome Dr. Satyanarayana. Floral.
विशाल पानी की बोतल दे. पानी को अच्छे से पानी वेस्ट हो जाएगा.
मॅडम मॅडम माझा टॉप कोणाला करता येईल तो बघ नाही
I would request Dr. Saran Pandey sir to kindly welcome Dr. Dr. P.P. Roy sir. I would request Rivakar sir to kindly welcome the Chiranjeevi. I request Dr. Swapnil sir to kindly welcome Ms. Jyoti Esna. I would request so we have witnessed these two days of the conference, were very knowledgeable and very interactive with the speakers which we had for these 2 days. So let us now revisit the significant moments and achievements of this conference. For this, may I now invite Dr. Rajendra Valedictory, Track Chair AI in Healthcare, to present the conference report of his track.
Thank you, madam. Good afternoon to one and all. Dignitaries present on the dais, researchers and their participants. It has been an honor to chair the healthcare track of this prestigious second IEEE DMI chair conference IDICAIHEI 2024. Over the past days, we have witnessed remarkable contribution and insightful discussion in the field of healthcare technology and artificial intelligence. On day one, our sessions began at 2 p.m. and concluded on 5:30 p.m. focusing on medical event processing, implementation of AI in healthcare, and pharma. We conducted 2 online and 2 offline sessions where total 55 research papers were presented by the authors. I extend my gratitude to the yesterday's session chair, Dr. IDICAIHEI sir, Mr. Naresh Chipane sir, Dr. Gaurav Mishra sir, Dr. Ujjwal Gajbel, Dr. Shivaji Tumrut, Dr. Manoj Chandak, Dr. Babaji Gevde, and Dr. Vaishali Kuchewar for their guidance and summaries added great value to the discussion. On day 2, the sessions began at 9 a.m. and concluded at 12:45 p.m. The themes excluded AI for augmented reality and virtual reality, big data in healthcare, removing data bias from AI and ML tools, and robotics and control system. Today, we conducted 1 online and 2 offline sessions where 37 research papers were presented by the students and researchers. My sincere thanks to the today's session chair, Dr. Jahir Kaji, Dr. Puneet Punjale, Dr. Vaibhav Anjankar, Dr. Anil Pete for their excellent coordination and insightful concluding remarks. Also, I am grateful to reporters of all subtracts, Dr. Praveen Kumar, Dr. Subodh Daronde, Dr. Ashutosh Bagde, and Mr. Samir Mete for their nice coordination and conduction. I really appreciate the efforts taken by all students volunteers during the sessions. They have done excellent job. On day 1 and day 2, total 90 papers were presented by authors in healthcare. Out of these 50 papers are presented in offline mode, and remaining 42 papers are in online. We show you practical applications and thought-provoking solutions. Research papers are from presented by researchers from University of North Dakota, USA, Sri Lanka, and Pakistan. The diversity of ideas and the quality of the research were truly inspiring. I would like to express my gratitude to all presenter, attendees, and session chairs for making this track a success. The active participation and insightful discussion have highlighted the immense potential of AI and advanced technology in transforming healthcare. Let us continue collaborating to drive innovation and create impactful solutions for the future healthcare. Thank you so much.
Thank you so much, sir. May I now invite Dr. Darsha Pajane, Track Chair, AI in Education, to present. Thank you very much, ma'am. So AI in education was one track which was multidisciplinary and everyone could contribute to this particular track. So totally we had around 183 papers, out of which 89 people of them were finally accepted by our reviewers. And then we actually had 50 registration in the AI education track. So 2-day session, as we know that it went in the offline as well as on the online course. We had 7 sessions totally for the education track. And obviously, coming to the theme of AI, where we all know that AI has revolutionized in education in the way we learn as well as the way we teach. So in that aspect, we got an ample of papers in this, wherein adaptive learning, personalized learning, tutoring, all these concepts were presented in those papers. Obviously, the best paper also we are going to shortly announce was what the best paper in our class. Let me take this particular opportunity to thank all the reporters and the session chair who had given their valuable time and listened to all the 15 to 17 presentations which were there for day 1 as well as day 2. So I take this opportunity to thank Dr. Manali Shirsagar ma'am, Dr. Ajay Thakre sir, Dr. Smita Lonkar ma'am, Dr. JKW Bakil, Ujjwala Gawande ma'am, Dr. Naresh Chichwane, Mr. Chiranjeevi Sistu, and then Subhash Shinde sir was there, and of course, so there. The reporters were there, Dr. Gayatri Chopra ma'am, Dr. Pawan Kumar sir, we had Dr. Prateek Verma, Dr. Lakshmi, and then we had Dr. Satya. Thank you very much. And the volunteers also very soundly, they made all the sessions go very smooth, like the online as well as offline. Even any technical glitch was there, they were ready to try. So thanks a lot for the education. Thank you. May I now request Dr. Soumya Mundewalkar to present the grant.
So for AI in industry track, out of 1047, 280 were related to the AI in industry track. Out of those, we have selected 106 papers, and finally, the registration happened for 98 papers. Now, for this 2 days conference, we have conducted total 10 sessions, out of which 5 were online and 5 were offline. For the online sessions, a rapporteur was done by Dr. Sarang Pandey sir, Dr. Naresh Nati, Ms. Neha Patle, and Ms. Yogini Sukha. For the session chair, like the people who have played the role of the session chair, Dr. Satyanarayana sir, Mr. Kalbande, Ms. Josephine Yes, Mr. Sistu, Dr. Karunakaran sir, M.H. Kori sir, and Roy sir. all those played the role as a session chair. After the completion of all the 98 papers, whatever we have got for the registration, this is the impact which I can summarize. Like research such as machine learning and AI approaches for the manufacturing applications, condition monitoring and fault diagnosis of the BLDC motor, precision agriculture and technology, highlighted the tailored AI solution to enhance the industrial processes and agricultural mechanism. Papers like the role of AI in transformative biomedical imaging and AI in healthcare data security and privacy showcase how AI is revolutionizing the diagnosis, tech health, and the medical data security, directly improving the patient outcomes. Research like explainable AI and the fraud detection, blockchain-enabled secure data sharing in the medical sensor networks, and the deep learning for the crop disease identification push the boundaries of cutting-edge technology for the practical and scalable solutions. By applying the deep learning models such as CNN and autoencoders to the agriculture and monitoring, the presented work demonstrated the scalable, data-driven approaches to food production challenges and ensuring the secure food supply chain and improved in the agricultural resilience. In the conduction of this today's conference, I would like to thank the technical committee, those who have conducted or help us in order to conduct those conferences smoothly. Also, we have received the feedback from various authors, and these are the positive feedback. And after my feedback, there will be the session where the authors will share their feedback or valuable feedback, which will help us in order to improve to the next level for the next conference which we organize. Thank you.
Thank you so much, sir. Thank you, Practice, for the comprehensive review. It is truly inspiring to see the breadth and the depth of discussions and collaborations that took place over the past 2 days. May I now request the participants and delegates to kindly share their feedback. For the same, I would now like to call upon Ms. Vaishali Palkar, Vidyalankar College, Mumbai, to give her feedback. She was in the invitation.
Thank you, ma'am, for giving me the opportunity to give feedback. It was a chance to express my attitude here. First of all, I would like to congratulate the organizers of the international conference. Really, major research events when you want to make a successful. The reason it is actually a successful event of numerous efforts taken by the organizers for the months. From the registration till date, smoothly. I think that I would like to say we got the support from support at every time, from the registration, from the paper formats has to be in every way. Especially I was in education, really helped us a lot. Thank you so much. I wish many more such events for the university. Thank you. Thank you.
Thank you so much, ma'am. May I now request Ms. Induni, AHS, TMITRU. She is from the track of AI in health.
Afternoon, Maranol present here. Actually, it's my great fun to participate with momentous occasions that will be in my chair. I will conference. Actually, because of lack of time, so I will short my speech. As I am in medical background, actually the 2 days program I attended and participated, and I paper as well. Actually, I would say it's wonderful because we don't have that much exposure to attend conference, and maybe if the conference is it's very far, so it's for me as I came from out of India, it's very difficult me to go. But here, thank you, sir. Thank you, ladies. arranging those kind of as researchers is good because we learn many things from our team features, not only in healthcare, in industry area, education. Thanks for the wonderful opportunity. So in coming future also, we are expecting more. Maybe we next year we'll be not here, but we'll be planned to join with in online also and also invite
Some after.
yeah, sure. Come if I get. So in my and also I hope I wish my fellow students also they also get wonderful experience by this 2 days program. So thank you for the whole DMIHR family and the PFP. So architecture Bhubat kindly give us feedback. He was from the track of IEEE.
Join
Thank you so much for making sure you were giving us this very enriching. Thank you so much for this very enriching conference experience. First of all, great thanks to organizers. Everything from the start went was very well organized. I got really good feedback to my papers and great support for enhancing its possibility. Also, thanks to Seven for small discussion and getting to know about your work and perspective was really helpful to look into the bigger picture. And again, thank you for the whole event. I would definitely like again to participate in such educational and knowledge insightful conferences. It really helps to get to know about what's all is going. So thank you so much.
May I now call upon Mr. Martin, SAS DMIHR for his speech.
And today I would like to appreciate the organizers of this program, especially this conference from the top management to the dean of it, Dr. KTV, so for this wonderful program that we have organized, bringing researchers, scholars together to participate, students also to participate. It was very, very helpful for me, especially. We were track and it was actually a very, very important experience for me for the first time attending the conference in person. So I would like to send my gratitude to my researcher, Dr. Deepa Sharma, for his guidance, for his wonderful guidance. So mostly, we have been a very helpful guide to of the research. I appreciate it. I also appreciate the hierarchy of this institution near management. Thank you.
Thank you so much, Martin. May I now call upon Prathamesh Belli from the Sciences Pune to give us.
Ladies and gentlemen, am I audible? So first of all, I would like to thank the entire organizing committee for such a fabulous and apple pie organization. Can we have a round of applause for all of them? But more than that, special thanks to Swapnil sir, Bala sir, and they have been there in that WhatsApp group answering the queries, all idiosyncratic queries rather, I would say, which used to come in the same questions people used to ask again. But without losing out their patience, they have handled it so beautifully, elegantly, with a lot of respect, and I really want to both of them. You should applause one more time. Also, Dr. Utkarsh, you are very fabulous yesterday on the stage. The way you have anchored, it's really, it's marvelous.
There are a couple of things I would like to share. So I would rather like to give compliment to Dr. Reddy for for probably heading the entire engineering division. I feel I'm 21 years late to this place because I got into engineering 21 years back, and all I learned was microprocessor 8085, which didn't make any sense in the industry. So you guys are really, I'm so jealous of you. All of you are really, you should be grateful to the institution that they are teaching you artificial intelligence, machine learning, which is the thing now, which is going to fetch you a job. So one round of applause for the entire institution. And the speakers selected were fabulous. Fabulous. I mean, yesterday, when I was presenting a paper, one gentleman walked in, and he was the judge probably, and once all of us presented, he was giving a feedback to students, and he said that you should be very passionate about your product. This is your product. This is not just a PPT. Don't just read it out. You should own it. You should know whatever is written, everything on the slide. But trust me, they say what they preach. This man had showed and displayed it today in his presentation. Can we have a round of applause for Dr. Satya Narayan? Such an amazing presentation for such a technical topic. It's very difficult. Once you will come here, you will realize that. Also, Dr. Karuna Karan, I wish I was engineering, it would have developed a lot of passion for engineering. So yeah, we should have a round of and towards the end, I would like to thank from bottom of my heart. I couldn't meet this person yesterday because he just said there was something, but I don't know what, but he just left early. That was Dr. Raghunath Shevgaonkar. One profound statement. I have taken 6-page notes when he was talking about. I was like, this attentive. I mean, what this guy is talking about? Itna wisdom tha. One thing that he was profound that probably I have not read in any of the 100 books that I've ever read in the self-help category. He said, what differentiates between learning and education? Jab AI की बात चल रही थी, AI will replace teachers and stuff. And it says beautifully that if you take out all the topics and the the curriculum out of the course, what remains is the education. What a lovely, profound statement. He's not here, but we should have a rousing round of applause for it. Thank you, ladies and gentlemen, for a wonderful audience. It was an awesome experience. It was the first time that I visited Varda. I like every single bit of it, the climate, the Bubbles Cafe, the place that I'm staying in. It was fabulous experience. Thank you. I would love to visit. Being a corporate trainer, I keep listening this from industry leaders, senior industry leaders. They say, academic research has no relevance with what we do in industry. I mean, this is what I've been hearing time and again when I say that I'm also doing PhD along with handling businesses. And they keep saying this statement, but this time, let me be very confident about it. This time I'm going to say them that अगर तुमको अपना perception beat करना है, तो आपको अगली conference in Varda attend करना. Thank you. Thank you.
Thank you so much, Professor May, for such a wonderful feedback. Thank you so much. May I request if anybody voluntarily wishes to give their feedback, they are all welcome. Anybody? Any of the students will also do. So, moving forward, may I now request Professor Dr. K.T.V. Reddy to address the gathering.
Ready to listen to me? Okay, so we stop saying good afternoon, morning, good evening, because we have started. Right. So, respected chief guest who is online, Dr. Uddhav Bhosle, who is the Vice Chancellor of Varadkar University, Kolhapur. They are listening to us. And due to emergency, is not able to come physically, supposed to come to us. If you would have been here, it would have been different difference. But anyhow, next year he promised that he will come in physical mode. Okay, so thank you, sir, being on online. And Yeah, so we'll listen to you very shortly. And anyhow, whatever feedback my lecturers are given and the people who are authors are given, thank you very much. But that is what we thought always. Anything to do it, there is always scope for improvement. So we do go for minute. We don't care. We don't push forward. If it is we are wrong, we accept it. We'll try to correct it in the next time. So as I announced in the inaugural time, our conference is going to be scheduled November 28th and 29th, not 29th and 30. 28th and 29th, that is Friday, Saturday, 2025 November. Okay, so maybe tomorrow, day after tomorrow, you can see the changes in the website, our website. The dates and other things will be reflected by Monday. Tomorrow is Sunday, so maybe we cannot trouble our people. By Monday, that will be changed so that you can think of now onwards. Don't submit at the last moment to the so-called good research paper. We expect the better than best papers in the future as well. Maybe we are thinking at least 5,000 papers should come in the next conference. Okay, so we'll have instead of 2 days, maybe we can extend 3 days also. We don't mind, but we want the quality. Okay, so as given the feedback that maybe we know internally what type of quality we have. We are sure that whatever the IEEE conferences happening, or maybe many of you might be attended in various places, starting of inaugural, starting of sessions, presentation by authors, 100%. This is the only conference in India or in abroad. Nobody, no conference have missing paper. Always there is a missing papers. No conference have 100% presentations. This is the conference which has 100% presentations. And thanks to authors for taking that spirit and being for this particular international conference making successful. Okay, so as already many times we are talking about vote of thanks and all, but I love and the affection shown by my university authorities as well as the session chairs and guests who have come all over India, even one person from USA. Okay, so we'll have more number of international people in next time. But still, this is the way. See, how many people like online? We don't know, but offline makes a difference. So interaction and discussion coming the best. And your whatever the perception we have, that will change into a different direction. So that's why the conference is required to get the confidence. So that is why we push our students also to go and attend and meet the people, right? So it is a meeting and gaining some type of technological knowledge and all. So anyhow, without no need of me to continue for hours and hours, because as a teacher we have a bad habit. Okay. So once again, from the bottom of my heart, thanks to each and every one of you to be with us and without what you like you said, we are coolly or people are answering, but that way they won't tell me that I am fully handling. Okay, so thanks to my team of each lecturer and each member secretary of this particular conference, timely taking care about each and everything, and especially thanks to our university, especially to be with us always for the success of this conference. Thank you very much. To reduce the time, if you like it, what we do is we'll call all the others, we'll give the certificate, we'll have one group photo. So giving one by one, it takes a lot of time. So are you agree with that? So we'll all the things, but come there and stand here, one group photo will.
I'll call upon the names of the authors who have presented their paper. Kindly please come on stage.
All of you come here.
Samli, Akshita Avkar, Vidya Thackeray, Sandeep Star, Deepak Sharma, Divya Darle, Hemant Khade, Monica Hegde, Suvarna Patel, Pawan Ajre, Pawan Payal Barodkar, Anjali Singh, Purvi Jekwa, Akash Mande, Shiv Sarode, Abhishek Raj, Ashutosh Vijay P, Yash Thackeray, Shreya Lonkar, Chirag Gujral, Anchal Rao, Sanskriti Shende, Tanya,
Track questions. So otherwise, what we do, if there is a confusion, so we'll complete the mandatory function. We'll keep what the registration does, so that we can collect that. But come for photograph there. So we don't want to make you unhappy. Just come for photograph. The Stars can come and stand up. Extras,
or I think also for the author certificate. An external certificate. Your authors?
Talk about that, then immediately. You want to you can come in.
So much everyone. Can you please settle down? Forward. Paper awards and all the three grants.
मेरा सर्टिफिकेट लेना बोला बार रजिस्ट्रेशन मेरा सर्टिफिकेट लेना बोला रजिस्ट्रेशन
One best paper in each track. Start with the healthcare track. I would request the diet to kindly be on it. For the healthcare track, the best paper goes Session Joseph, Neeraj Joshi, and Soumya Singh. They are from the Kota University and University of Texas, USA. And the topic was hybrid BGT SPM framework for melanoma detection, integrating GA and augmented data and analysis in the creativity. So, a round of applause to the
This author is from US, so we know other two authors.
next is for AI in education track. What best paper? Vijaya Gasa, Satya Kumari, and Naresh Nathi. They are from the University of Andhra Pradesh. and Dr. Valedictory is from our university as well. So the paper title is How IFT Interactive Lab in AI Affects the Achievement in Rural East Godavari District Secondary School Objective. We have the authors online because they are not.
Thank you. Thank you, ma'am.
उनको सर उधर से
By the time, ma'am, if we are audible, can we just have a small feedback from your side?
Yes, ma'am. Am I audible, ma'am? Good afternoon, one and all. My name is Vijaya Kasa, a research scholar from Andhra University, working as school assistant at ZPHS Domeru, a rural area from East Godavari, Andhra Pradesh. It's a great honor to be with you all world-class eminent personalities in various fields, striving hard to leave your mark for the better and sustainable world. I thank my co-author, Dr. A. Satyafani Kumari, HOD of ANITs, and Naresh Nati of DMI for the great support they have given for this paper. I thank the entire team of DMI for being so patiently guiding us in each and every step. So if we are here, means that is because of the DMI team only. So patiently they guided. And Pratik Verma and Chaitan Puri are a few among them. My paper mainly discusses how effectively the technology and the AI can integration can bring change in the learning outcomes of secondary school children in the rural area of East Godavari. So as Chagallu and Kovuru are near my school working areas, I have taken their learning outcomes and I have did this one, and I strongly felt that not only technology, AI integration had made them successfully, they are able to speak and express their feelings, and they are able to create digital content, and they are able to provide authentic solutions in their real life situations. So I strongly believe that AI is going to make its mark on the education system. Thank you for this wonderful opportunity. Thank you. Thank you all.
AI industry goes to Pranali Mavde, ANLV and Palimesha from the Department of Computer Science, PRPCM Amravati. Title of their paper is Design of an Improved Model for Nutrient Deficiency Detection in Plants using CNN, Auto Interference and Site Precision and Aware. It's also there online.
Thank you so much. Good evening to all the respected dignitaries on the dais and off the dais. I'm deeply grateful for the opportunity to present my paper at Second International Conference on Artificial Intelligence in Education and Industry 4.0, organized by DMIHER. It was an honor to share my research with such an esteemed gathering of scholars and practitioners. Actually, I am the research scholar at PRMITR Badnera Institute. My PhD guide is Dr. A.S.L.V., who has guided me a lot from beginning. I would like to take this opportunity to commend the organizing committee for their exceptional efforts in planning and executing such a well-structured and engaging conference. From the seamless coordination of session to the thought-provoking keynote addresses and insightful panel discussion, it was an evident that meticulous planning and hard work went into making this event such a success. The attention to detail, dedication, and professionalism of the committee not only facilitated a smooth experience for presenters like me, but also created a welcoming platform for meaningful and academic exchanges. Thank you once again for your unwavering support, encouragement, and for making this enriching experience for my lifetime. I look forward to future opportunities to contribute and collaborate within this vibrant and academic community. Thank you so much to all the dignitaries. Thank you.
Congratulations to all the authors. We are honored to have with us today Honorable Dr. Utham Bhosle, Vice Chancellor, Sanjay Gunapur University, Kolhapur, and chief guest for this celebration. Just like to introduce him to you.
He is from, PhD from IIT.
Now request Dr. Utham Bhosle sir to kindly address the guest.
Very good afternoon. In fact, very good evening to one and all. Dignitaries on the dais, the president of this validatory function, and the Pro Vice Chancellor of this university, Dr. Gaurav Mishra ji, the Dean, Faculty of Science and Technology, and good friend of mine, the Dr. KTV Reddy, Dr. Gaurav Mishra, Dr. Satyanarayana, Professor K.K. Karunakaran, Dr. Sarang Pandey, in absentia, Honorable Sagar Ji Moge, Honorable Vice Chancellor of this university, Dr. Wagmare, participants, delegates, ladies and gentlemen. It is my indeed great privilege and honor to accept the invitation of this validatory function of International Conference on Artificial Intelligence in Healthcare, Education and Industry, organized by Datta Meghe Institute of Higher Education and Research, deemed to be university, known for academics, research and extension activity, not only in the state, but in the nation. Organized by the Faculty of Engineering and Technology under the leadership of Dr. KTV Reddy. I am thankful to the authorities of this university, Honorable Vice Chancellor Dr. KTV Reddy, for extending the invitation and to be a part of this August gathering today. I intend to attend this function physically, but due to some official and personal commitment, I decided to join this function in a virtual mode. During this validatory function, organizers of this international conference presented the brief report on the conference, number of how many papers have been received, the places from which these papers have been received, number of invited talks, plenary talks, then papers in different areas, particularly health, artificial intelligence and its application in healthcare, education and industries. So really, this conference, according to me, is a successful one. So I congratulate Dr. KTV Reddy and his team for successfully organizing this international conference. Dr. KTV is a well-known team leader, is a well-known mentor. He is known for his ability to organize such national and international conferences in the previous organization and in this organization too. He has extended a platform for the researchers, working professionals in different fields to share their experience on use of artificial intelligence in various aspects or in various aspect, I would say, in the various aspects. Now, when we talk about the changes, when we talk about the change is, according to me, the change is a constant process and change is directly proportional to the time. Nowadays, you find so many changes in science and technology. And science and technology changes in the science and technology is impacting almost all the systems that we have here. The changes in science and technology is impacting not only education system, but it is impacting our social system, our economical system, our political system, and many more. However, the impact of changes in science and technology is more on education sector compared to the other sector. This is my opinion. We talk about industry 4.0. Now, many of us are talking about industry 5.0 and the 6.0. So when we talk about industry 4.0, we talk about automation, robotics, control, Internet of Things, industrial Internet of Things, and so many. Now, we also in education, we call education 1.0, education 2.0, education 3.0, and now education 4.0. In the era of National Education Policy 2020, and with a in the view of changes in the science and technology, I called we are in education 4.0. In education 4.0 demands education at any time, education at anywhere, and education on demand. Education on demand, education at any time, and education at anywhere. Therefore, the role of science and technology is playing a very vital role in today's education system. Today, the role of the teaching methodology has changed tremendously. At the same time, the role of even teacher has changed a lot. Now, when we talk about education system, then the education system we talk about multidisciplinary education. And this was the theme of this today's conference, where use of artificial intelligence in the different field. Education now it has become a multidisciplinary. At the same time, there are no fixed boundaries. During our days, there were some boundaries. We call it as science, commerce, engineering, medicine, so on and so forth here. But now education has become a very, very multidisciplinary education. When we were studying at IIT Bombay, then at that time in IIT Bombay, we saw only engineering departments. But in due course of time in IIT Bombay, today, we along with engineering and technology, we have the departments from interdisciplinary studies, department from social sciences, department from educational sciences, department from even biosciences too. At the same time, today, if we see the Indian Institute of Technology Delhi, IIT Delhi is having association with Indian Institute of Indian Institute of Medical Sciences Delhi for interdisciplinary research and the collaboration. At the same time, Indian Institute of Kanpur have started a medical college. Means you see the changes in the education system, and these changes are happening only and only because of the changes in science and technology that we talk about. So, talk about. So in this changing scenario, we need to be very, very particular about these changes, and we need to adopt the changes in due course of time. So according to me, so initially when we talk about the developed countries, so we call the developed countries are those countries. This is my own perception. We call developed countries are those countries which have a muscle power or which can win the any flight, or which has muscle power, money power, or military power, who can rule the other countries. But according to me, today the definition of developed country has changed. The countries where education system, social system, and financial systems are very strong, these countries are definitely a developed country. And for the developed countries, and when we talk about the definition of a developed countries in present perspective, then entire world is looking at India, and we many times say that India 21st century is the century of an Indians. So when we talk about the centuries, United Kingdom, we call 19th, 18th and 19th century was the century of UK, United Kingdom. 20th century is century of America, USA. Now 21st is the century for an Indian. So in America, why America becomes so great country? America has become so great country only because of research, innovation, technology transfer, product development. And so these are the factor most important for the development of this country. So according to me, for India also, we need to work on this four aspect. Narendra Modi ji, Honorable Prime Minister of our India, has coined the word Atmanirbhar Bharat. We want India to be Atmanirbhar. We want India to be a self-reliant. But India will definitely become self-reliant when each and every institution, each and every organization, each and every state and individual becomes self-reliant or Atmanirbhar. And for our universities and educational systems in India, in order to become an Atmanirbhar, in universities and education systems in India have to work a lot on research in multidisciplinary area. They have to invest too much on research. They have to invest too much on innovation, invention, technology transfer, and the product development. So I think Datta Meghe Institute of Higher Education and Research will definitely take a lead to become a Atmanirbhar University or self-reliance universities. This conference has extended a platform for different researchers, working professionals, working in different field or different field. Now everybody is talking about artificial intelligence. What is the role of artificial intelligence? How AI we can effectively use in particular application? What are the risks associated with artificial intelligence? All these things here have been discussed in, I think, in today's conference. So with this, I conclude because I have one more meeting. So I have one more meeting. So with this, once I conclude, before I conclude, I once again extend congratulations to Dr. Reddy and his team for successfully organizing this conference. At the same time, congratulations and best of luck for the delegates, participants for attending this conference. And I definitely make sure that when Dr. KTV Reddy and his team organize such conference, I will try to attend this conference workshop invited talk in a physical mode. Thank you. Thank you very much.
So, mentioned, I'm not going to speak anything technical. I want to stress upon just 2 points. One, of course, I will talk about the conference organization, and also I want to give one message. Possibly some of you can take home. Many of you must have heard yesterday and today, maybe when I shared some session. But those of you who haven't heard it, maybe I'm sorry if it is a repetitive for other delegates. So let me be brief. The point is, what is being organized is a research conference. The conference where we want to, all of you young people, want to present a work of yours, right? Some different areas of the organization. And so therefore, in order to present work that you are very enthusiastic about, and of course, you are at that kind of age, it's really a great thing that you are able to actually write down a paper and want to present. And very nice, you have presented excellent, great, excellent presentation. But the genesis of all this is the research. The research where research is something which you kind of do a kind of investigation of some area of your choice. But the example that I was giving some of you explained today is it is that little piece of work which you own. It is your baby, it is your property. Not during your life, it is beyond your life. Because even after you die, whatever it is, you are still referred to by the work that you have done. That is our differences. That is a difference 4, 5, referred to by the name of the person who actually did that work. Of course, it is typically a team of people, and depending on your choice, you actually refer the paper by the first author, something at all. Remember, this is a well-founded value, whatever it is, they call IPR or whatever. This is something yours. So necessarily means the presentation requires presentation and conference, research conference requires the original work that you have done back in your college, your lab, your house. Don't forget. So the genesis, the seed of the presentation comes from original piece of work. Now the question comes, can all of us be Einstein, Pascal, Maxwell? No, we are not. So we only do a little bit of thing. It doesn't matter if that work can also be done by somebody else. Imagine there was no internet. There is no communication happening. There was parallel research that was happening in countries like US. But all of you can say that this is my work. Yeah, you also have done it, but I have no idea that you have done it. This is original. It's work in the history of science, history of technology, history of engineering is your piece, your space. It is being in the history. So please remember that is the beginning. So next time when you present, when you submit a paper, take a work that I'm going to kind of do that little piece, and that is what I'm going to write a paper on. I'm not even going to copy paste anything from the literature, nor I'm going to summarize what is happening elsewhere. Right? So this is our pledge today. This is what happens when we organize the third conference. I want to come, I want to see, I want to compare and say that there is a bracket straight that are done in the part of the presentation. Okay, but that doesn't mean to say this conference is any less than you have seen the real tributes that were paid by experts, and most importantly, you people talked about it. I join you by complimenting the organizers for beautifully organizing this conference, even the last one. And we are looking forward from today onwards. He has only promised Monday we are all going to Google and make sure that the third conference comes online. And I will be happy to come again with e-calls. And I want to really enjoy this great atmosphere of intellectual learning, and especially yesterday morning, all the videos, all the keynote talk. Today, hearing wonderful enthusiastic presentation by all of you made me much younger. And wish all the best in your future career, future reviewers, whether you choose to come to research, you choose to do industry, choose to do higher studies. But I'm sure this seed of what you did today and yesterday is going to come with you forever. Thank you very much for this opportunity.
Thank you so much, sir. Now the rest of the team and
Very bad in talking without example is very difficult. But I know Professor Reddy for almost 2 decades now. He has been mentor for my first college for a long time. So whenever he calls me, I come. And coming here was really a very pleasant experience last time. This time. And I saw the bubbling enthusiasm with which all these people were organizing the event, young students. Always doing an excellent job. So my sincere appreciation and congratulations. In addition to that, having my that fast, I just want to quote one Tamil song. Gautam Buddha required a tree under which he sat, meditated, and obtained jnana. Okay, this poet says the entire sky is my body. So can you imagine the entire sky is my body? That's what I told in my session. That we grab the opportunity and interact with the speakers of the session. So the knowledge comes from everywhere. Inanimate or animate, young child or old people, everybody is transmitting knowledge. When something is transmitted, as electronic engineers know that made an antenna. The antenna has to be tuned to that frequency. And it has to look in that direction. None of these happen when you miss the knowledge. The knowledge keeps coming. It is your responsibility to tune the antenna and then capture it. I keep looking at myself. I've been missing many things. I lost some time and then I understood. For example, we developed the sand. Somebody in Bajaj Auto told me 12 years ago. But I missed that idea. After 5 years, I understood. Then we got funding of 5 crore build a sand building. Last time, it took 12 years to build a machine. Whereas I started. So all of us are missing the signal at many places. So we have to be conscious of. That is one I want to say. That line in Tamil, it is called Vanam Janakol Bodhimana. The same song has another interesting line. It is query. Question everything. Queries are nothing but a kind of tenants. When the word used in Tamil is very, I don't know whether it is Sanskrit also. So, கேள்விகளால் வேள்விகளை நான் செய். Questions only will make you understand more. Like I can start giving some more philosophy. Okay, let me not take too much of time. Thank you very much. All the best to all of you. And once again, I appreciate you and congratulations.
Thank you so much, sir, for your wonderful words of wisdom. May I now call upon Dr. P.P. Roy for the wisdom.
It's not a problem. I'm not going to be like. Okay, so to be honest, I came to this conference to meet my friend. I want to meet his friend. At this age, but I would say, we also learn. We learn. That was definitely a learning. My one suggestion I have is the interaction type. I understand. What is the feedback of that also we have feedback. It's starting little more. Almost impossible to handle. I know. Each one is going to experience. That is not the team that driving. That is the kind of thing for the. I interact with a bunch of people. I travel with the staff. It's very exciting that they gave he actually how he is doing very well. Interacted with one fellow. So I think probably for the next conference, you should have stories, some experience, or some presentation, some perspective, but that is very important. Happy to say that what it provides. I mean, generally, in a private college, to be honest, aware that I was not really aware. I really appreciate the management. They are open. They are only
kind of a remote play. And also they are very up to date. That is really great to see. There are a lot to learn.
May announce for the content. Chiranjeevi uses
You need to all take care of the very grateful. I would have say, but I would like to point so like even 8 minutes of the song. That's what I see. I don't know. You know, but that's what we see. I think. Then you can spend on the methodology and then you can what to teach to the methodology. So that's one part of the cover. Second part is why people is always there to stand with because the industry, the results matter. The results matter. You are filing things and coming back best of that one. Going facing that there is a need of AI. The experts to show that there is a need of AI. They stop. Like like you stop like for me. So maybe, but I thought that I see